Thank you, Tommaso and Jack and everyone here. We're very happy to be presenting here. This is a paper that we think has a lot of relationship with the PER project in general. I'm going to talk a little bit more about it. So I'm going to be presenting this paper that was already published in 2024 on quantitative science studies, large-scale text analysis using generative language models, a case study in discovering public value expressions in AI patents with my co-authors Gaurav Verma, Barbara Ribeiro, and Philip Shapiro. So let me begin with some context. One, I'd like to highlight our similarities with the PER project. As I was saying, we're both interested in research and public values in emerging technologies, and in particular in AI. We're not only interested in that, but also interested in methodological development so that we can operationalize that concept so that we can actually extract like observable entities of public values in whatever piece of text that we're looking for or any other source of information. We're also interested in alignment of several kinds, but one of them is the alignment between what is said and what is done. And that's work I know you have been doing and we're also working on. And how all of this can be used for early signaling of emerging technologies implications and societal implications. So we do see a lot of relationship between our work. The second thing I'd like to say is the context of how this research came to be, because I'm going to be talking about this research that is mostly methodological instead of like policy-oriented, because we have the policy-oriented research after this one. So just to give a little bit of context. So we started in the spring of 2022 with not having in mind to do a methodological paper. We wanted to do policy paper about public values in patents. And we had the prior research that my co-authors, Barbara Ribeiro and Philip Shapiro, had already published in Research Policy in 2020, where they had already found examples of public values in patents, in particular in synthetic biology patents, doing qualitative analysis of over 100 patents. So the question we faced was, what if we want to do this at a large scale, do it for hundreds of thousands or perhaps millions of patents? And the workflow was the standard workflow at the time when generative language models were not available still for the public. And the workflow was do the qualitative coding to get a set of examples and get to a critical amount, at least say 1,000 of those examples. And then once you have those examples, you can give it to a transformer discriminative model like a BERT model that is going to be fine-tuned on those examples, and then it's going to learn the task that you gave it, and it will be able to be deployed on a large-scale database of unseen examples. So that was the plan. We started coding the sentences, doing the qualitative work, which was separating batches of sentences for each member of the team, and then having regular meetings to discuss our coding analysis and differences. And we did that for a few months, and we saw a steadily improvement in our agreement levels, but also it was time-intensive and labor-intensive work that took great amount of time. And then in September 2022, around that time, we decided that we needed to have a conceptual framework to actually guide this work, because we needed more like a deductive device, something people could go look at it, and then when they saw an example, go to see the conceptual framework and then just derive a label. So we wrote a conceptual framework with definitions, guidelines, examples. And the idea was that human annotators would see the framework and then would label the sentences. And that actually helped a lot. We increased our level of agreement. It was easier to understand where our differences lied. And then around that time, OpenAI made GPT 3.5 available to the public through their chat interface. And then around March 2023, they also made it available on their API, along with the more powerful GPT-4 model. So we decided that we had the conceptual framework already crafted in a way that it could be given to a generative model. And maybe we could test if that generative model was able to generate labels, thousands of labels, many more than we could do humanly, and to see if that could work. So that's how this worked, and that's how we decided that we could do a methodological paper to begin with, before we engaged in the policy research question that we were interested in. So I'm going to talk about that methodological paper mostly in this presentation. So the questions turned out to be, how can we use an LLM, and in particular a generative model, to produce labels and rationales for text classification of complex and abstract concepts that are very common in social sciences? How can we test the quality of those outputs of those labels and rationales? How can these labels be used to then train open source classifiers like BERT models, and whether that can be a successful workflow instead of the initial qualitative quoting plus BERT? This would be a generative language model plus BERT. And what are the implications for social science research? So the case study that we were going to apply this to was public value expressions in AI patents. We were following the tradition of Boseman's public values, and I like this definition of Rogers, which defines public values as enduring beliefs that are founded on an ideal of human society. As a result, they offer direction, meaning, and legitimacy to collective action. So this can be thought as very high-level societal goals, such as justice, transparency, accountability, fairness. Many of those goals are actually included nowadays in AI principles and governance. But these very high-level conceptual framework has proven difficult to operationalize. This is something that Boseman and his co-authors actually have identified while they've tried to operationalize that concept, because public values they can be vague, ambiguous, they can be implicit, contextual, they can evolve over time, there can be some hierarchies among them, and they can conflict with each other. But we were following the example that my co-authors had already produced on identifying these types of expressions in patents. So we believe that surprisingly, patents can actually be an interesting place to identify these types of statements. And we created a definition that emphasized the ability for us to operationalize the high-level public values concept. Now, so we define PVEs in patents as broad optional written statements within a patent document that outline societal problems or propose potential solutions. So two things to highlight here. One is that they are broad in the sense that they are not narrow technical or legal language that actually most of the patent is about. So these are more like high-level goals, societal goals that the patent is talking or proposing. They are optional in the sense that despite they can be used for patentability discussions, they are not required. You can get a patent granted in the US without any of these types of language. And then we differentiate between those sentences or paragraphs that outline the problem. We call those contextual PVs, and those where they directly mention the invention being the one solving the problems, which we call direct PVs. But this covers all of those aspects of the definition. So let me give you a couple of examples that we have in our database. So this one says, and this is a contextual PVE, malicious network information has seriously impacted and threatened individuals, enterprises, and even countries, as well as safety and social public interests. So you can see that you can easily map this type of expression to a public value, for example, a public value of safety. The second one reads, and this is a direct PVE that we identified through the pronoun it, which refers to the invention, but it sometimes also says something like this invention or an embodiment of this invention or this disclosure, and that's how we identify this direct PVE. But in this case, it reads, it not only expands access to quality patient care, especially to rural regions and underserved populations, but also provides a way to cut down healthcare costs. So it's something that you can also easily map to broad societal goals. So these are the types of expressions we are looking for. So this workflow here is summarizes our approach for this paper, where we first obtained the data from the just patent text from the USPTO, and in particular, we were interested in specific sections of the patent where this type of narrative language is more likely, instead of the technical, dry legal language that covers most of the other sections of the patents. So the sections we're interested in are the abstract, the summary, and mostly the background text of the patent. So only those sections of the patent we get from the USPTO. Because we were interested in AI patents, we developed a string Boolean search using a tool called Innovation Q+ to give us a list of AI patents. We merged both those outputs, and we got a merged data sets of around 155,000 US AI patents from 2005 to 2022. We split that into sentences, which keep more semantic coherence, as we were saying in the previous examples. But for that reason, they are also easier for machine classification. So they give us over 5 million sentences, which is a very sparse set, because most of those sentences are not going to be about Pauling values, because patents are not about Pauling values mostly. So we needed to filter that and shrink that to dense subset. So we used keywords for that, 320 keywords from AI governance and AI ethics literature. And then that gave us around 10,000 of those sentences. So that was the subset that we gave GPT together with the conceptual framework that we had already developed. That included definitions, guidelines, examples, and rationales. And one particular thing we called positive heuristics, which tell the model what to do, and negative heuristics, which tell the model what not to do. And then ask it to generate labels for each of those 10,000 sentences, together with rationales, which are like justifications for its labeling decision. And we developed a couple of methods I'm going to talk about more later to assess the quality of those outputs using blue scores and topic modeling. And then the aim was using that as a training set for open source discriminative models like BERT, so that we can have a trained model, a trained BERT model, and then deploy that on millions of unseen sentences. So that was the workflow. Let me show you some examples, some results. First, the results of the example generation performance. So how did GPT-4 performed? And the first thing to say is that GPT facilitated agreement among human coders. So as I was saying, we took some time to meet among human coders and explain our differences in our coding decisions. And there are some issues with Pauling values literature, in the sense that there is this gap between the concept itself that is very, very high level and how to operationalize it. And making that a bridge is sometimes difficult even to manifest or to make explicit. So it was making that a standardized rational or justification difficult and time consuming. And we found out that GPT-4 produced labels with justifications or rationales that were standard and convincing, in a sense. So our agreement increased significantly when we moved from just human coders to GPT-4 and human coders. The second result is this one about the method we used with blue scores. So blue scores are a text similarity, an n-gram similarity method to identify whether two strings of text are similar or dissimilar. In general, what you should see here is that lower values means that they are more dissimilar. When we're looking at a set of sentences or paragraphs, so that means they are more diverse. And when it is higher, they are more similar. And we have three columns. The first column is showing the similarity among the examples we gave GPT-4. The second column is showing the similarity between the examples we gave GPT-4 and those it generated. And the third one is only those GPT-4 generated. So what you can see is the first column shows very low blue scores, meaning very high diversity. And this is, of course, on purpose because we wanted GPT-4 to see a diverse set of polling values. So this is good. And then the main behavior we wanted to see was something called faithfulness, which is whether GPT-4 was following our instructions or our prompt or our conceptual framework. And the evidence for that would be that the similarity between the examples we provided and those GPT-4 generated increased significantly from those we provided. And that's what we see. So the second column is showing that in general, that subset became much more similar, which is showing evidence of GPT following our instruction or evidence of faithfulness. And the third thing we wanted to see is that even within the generated examples, GPT-4 generated examples, we kept the high diversity because we didn't want it to get stuck with only the type of examples that we gave it. We wanted it to be able to internalize and understand what public values is in general and how to apply it to patents and be able to apply that knowledge to any type of unseen example. And what we see in the third column is that is actually also happening with relatively low values, meaning they are still highly diverse. So the output that GPT generates is still highly diverse, and it's not getting stuck with a specific type of topic or theme, which is something we also do with the second method, which is using topic modeling. In this case, we ran topic modeling algorithms on the rationales that GPT produced, and so whether it was able to reveal or to discover new topics that were not included in the examples that we gave it. So we gave it a few examples that covered 4 topics, four of these that you see here, and it was able to generate different topics, at least 6 additional topics. So both of these behaviors, the faithfulness, the diversity, and the ability to reveal new topics suggest that GPT was able to internalize our conceptual framework and generate labels for new unseen examples. The next question was whether we were able to use those examples to make to fine-tune discriminative large model to make predictions on millions of sentences. And for that, we used these 10,000 examples that we had to fine-tune family of BERT models and see the performance, the classification performance on a held-out testing set. And what we saw is that if we focus on the best performing model, although all of them perform pretty well, but the best performing model, which is the largest one, the Beta XXL V2, we see that it achieves very high levels of accuracy of 0.93 and F1 scores of 0.91 in the 2-class classification of identifying whether a sentence is a public value or not, a public value expression or not. So the result of this would be that we have a database with, we could say, for example, we can construct then or process columns like whether a patent has at least one public value expression, we call that presence or occurrence. Or also we can construct columns that say what percentage of the patent is dedicated to public value expression. So we call that density. And then we have basically variables that we can use for subsequent analysis of many types. So I'm going to show you just some examples of what we can do with this and what we're doing. So we can do some descriptive statistics. We've seen that PV presence they are present but not pervasive. So something like 40% of patents in AI patents in the US have at least one of these expressions. We can then run topic modeling to identify what types of topics these expressions are about. And you can see that the distribution follows closely the topics that are relevant in AI ethics and governance literature. And we are also doing several other applications. So in another paper with the same set of co-authors, we are asking whether PVEs can influence a patent's private value, and this will let us delve into another dimension, which is what is the role of these expressions in the patent system, because it can be a little bit of surprising or paradoxical. We are also asking, and this is similar to the alignment issue that I was talking about, whether PVs are actually substantiated by any other core characteristic of the patent. So for example, the technical capabilities. And this has to do with whether you are able as an inventor to do what you say. And as I was saying, this is something that I think also is interesting for, or interest for the PER project. And finally, we can identify what are the systematic gender and institutional differences in PVE usage. So these are all other papers that are more on the policy implications of this analysis instead of the methodological implications that is the paper I'm presenting right now. Let me know, Tommaso, how am I doing on time, just to see if I finish here.
I think you've used all the time, but
Okay.
thank you if you want
Because
to.
because this is a little bit of I think we can just leave these to the discussion or questions just to give more time, because I have some methodological implications and policy implications that but let me just have this time for the audience to raise some questions.
Thank you very much, Sergio. Very interesting and very nice overview. So let me open the floor for anybody who would like to add questions in the chat or in the Q&A. As people seem to be shy for the moment, let me start with a question, Sergio, which is not very different from the question that I was asking before the previous presentation. So think about now the contribution that different inventions can make to societal challenges. And obviously, as you've shown, you can write that because you think that that particular invention is definitely related to that particular challenge, and as an inventor, if you want to show that that is the case. But then you may have, I don't know, a lot of inventions, for instance, for smart agriculture, which do not mention any of these values. They're just purely technical. They're, for example, Internet of Things type of patents, wireless patents, or improving the connection in areas in which the connection is not very strong, so that it can be used in countries where you have very weak connections. But all of this remains very technical.
Yeah.
And so how do you capture that, and what is your sense about what you may be missing by not looking at inventions which could have value, but simply because they're inventions, they don't feel obliged to write that value in the patent?
That's a great point, and that's a point we have thought about a lot. Actually, to the point where the second paper that I showed you here, with each co-author with Diana Higgs, tries to answer that question in some specific way, where we are. So the general question we're asking is, there is a gap between there could be a gap between what is being said, like the rhetoric or the narratives of these public values, and what the patent does. And this can go both ways, as you say. It could be that there are some patents that are targeting societal issues, but they just don't say it, or they don't say it in a way that resembles public values. Or there are those that say things that they don't do. They say things that they are public values or they're societally relevant, but then the invention cannot do those things. So one way we addressed this in this other paper was we used a mapping that is already done by LexisNexis between CPC codes and SDGs. So that's connecting what the patent can do, because the CPC code is the technical features of the patent, to societal orientation, and then seeing if there is any relationship between that mapping and the public value expressions that we are seeing. And when we found that there is indeed that relationship, like those patents that have more public value expressions have CPC codes that are linked to societal issues. So let's say technological capabilities that are linked to societal issues. And those that use private value expressions, which is something we developed in this other paper, are less related to that. So this could be one way to do it, but to answer your question in some other way, that's an open question generally. We are mostly assessing discourse in this research, instead of what the patent can become and what the invention can do. We don't follow the invention's life over when it becomes commercialized, and when it becomes commercialized, what it does. That's something we kind of do, and that's something that we'd love to do. It's only that the data for that is more difficult to get, but that's definitely one of the big next steps.
Thanks. I mean, one potentially very, very immediate solution would be to look at, because they're using USPTOs, where citations are, patents actually do cite other patents much more than the European Patent Office, for example. So maybe you can look at groups of patents which are similar because of citations, going a little bit more granular than CPCs, which these are classifications which are given by the examiner based on technology, not necessarily by the use of that patent. But by clustering perhaps those patents in groups, like has been done in publications, you can perhaps see which are the groups of patents which can address the similar issues. And some of them may mention the issue, some of them may not mention the issue, but all of those that sort of combine because of citation, for example, they are all very similar. Because in our case, for instance, when we look at SDGs terms in patents, we find a very, very small amount of patents that have these terms across the globe. But let me leave it to, I think Dror has a couple of questions.
Yeah, I really liked the procedure that you show here. So my first question was, what right away jumped to me is even using this on like the data that I presented. Like, do you think it's generalizable? I don't know enough about patent text, but if you throw it on other text data. Two other questions I had on the procedure, which I might have also missed while you're doing it. First, you talk in the beginning of this importance of context when identifying public values and discussing it. So when you use the sentence level as an input to the GPT, do you have any sort of context that you do there, or is it just at the sentence? And the last thing also is just a clarification. The accuracy scores that you mentioned, are they based on that same sample that was given to the GPT? Or do you go back to your original corpus and take out new sentences that were not seen by the GPT and then test your classifier on it?
Yeah, those are great questions. Can you remind me of the first one? Just
if it's generalizable, if you could.
Oh,
use
yes.
if I could use it on my data, basically.
Yeah, no, definitely. I mean, the implications or the discussion I didn't get to it for the time constraints here are about that, and we believe that this is something that can be applied generally to any type of social science research where you have text and where you want to identify. And I mentioned social science because we were testing this on a concept like public values, which is something that has the characteristics of social sciences, something that can be vague, can be ambiguous, can be the high level concepts that the gap between that and the operationalizability can be big. So that's something that can be done in many other realms where this could be a feature of the data or of the concept. But the workflow is definitely what you can do and what was done before, as I was saying, generating examples for a machine learning classifier, and then just fine-tune that machine learning classifier to be trained and then deployed from those examples. So that's definitely something that we believe can be used. We also warn on there are many ways in which it can go wrong, and there's research that has exploded in the last couple of years on whether LLMs can be used for qualitative research, and there are many pitfalls that we should be aware of. So we believe like there are some important things like keeping human in the loop, like doing this supervision with examples to check the reliability. Like doing some the LLM can be very can have a lot of variance in performance. So doing something that like bootstrapping, like generating examples with one model and then generating examples with another model, and then seeing if there is some error between those, and then changing the prompt. So it's something that can go wrong, and there are like some best practices that should be followed. But in general, I think this is a workflow that should work for many applications. The second question was
context of sentences.
Oh yes. We didn't give context to the classifier. So I mean GPT. The issue with GPT is a little bit more complex because I mean both GPT and BERT are both pre-trained models, so they already know a lot of the English language and context, and they, in particular, GPT already knows a lot of in its training set of public values. So it may have in patterns and everything we need for this. So that's one type of knowledge that it already has. We then gave it a conceptual framework where we gave it definitions, examples, rationales. So it already also has that context. And then what we ask it is, based on all what you know about the world and all of you, and in particular all of what you know based on our conceptual framework, then make this classification. But then the classification is standalone, is only the text and the sentence, so it doesn't know more about the rest of the pattern. And the last one was the accuracy measures. The ones we're showing on the table are compared to a held out testing set among those that GPT produced. We also have the data compared to the ones that we like as human coders had produced, and but that's not the one included in the table. That was also pretty high.
So ones that hadn't been seen by the GPT as examples.
Oh no, this hadn't been this. No, I mean this hadn't been seen by BERT, so that they are technically out of sample for BERT, because but the ones we're showing here were already are part of the subset of those examples generated by GPT. But it's a held out sample, not seen by BERT. So it's reliable in the sense that BERT was not trained on that specific sample we're testing to.
Okay.
Thanks, Sergio. I have a few more technical questions, but I see Jack with a raised hand.
Well,
Jack,
Tommaso, why don't you come in with them? Because
No. I think we should probably open up. If you have a more general question, I think it might be more interesting for the audience then.
if that's helpful. It was really well. I mean, firstly, just to say to both teams, thank you so much for coming and presenting the work. It's so useful for us and so interesting for our project to hear from this and think about how we can build on it, add to it. My question was really just it's something that, so Barbara's point earlier about, I guess it's sort of almost a reflexive question, which is that as AI attracts more political attention, we can expect a form of reflexivity in which researchers in this domain and inventors in this domain know that they might have to engage in a sort of mode of justification, which leads to perhaps the you know, the expression of something that looks like public value in these statements, whether they are patents or papers. And as social scientists, we might distinguish those sorts of justifications or rationalizations from something that's more like an upstream motivation that might actually, you know, be about problem choice, be about the direction that the research is heading, rather than just a justification for what happens to have been done after the fact. And I wonder if in your explanations, especially using these unstructured data techniques, there's any prospect of distinguishing between the two, you know, distinguishing a post hoc justification from something that looks like a real motivation for this is why we did this research and went off in this direction and not the other direction.
Yeah, I just want to say if Barbara or Phil, you'd like to jump in. If not, I can answer, but just wanted to give you the chance.
Well, thanks. I can say maybe a couple of quick things, and maybe then Sergio, I'm sure you have more to say than I do. But it's just to say that I think maybe this sense of genuine motivation. I mean, it's something that you cannot really capture, right, from just analyzing text. That would be impossible. You have to, even speaking to people, it would be very difficult to make sure that we can do that assessment. But I think one thing that helps is maybe we did direct versus contextual PVs, in the sense that the contextual PVs will be like broad, sort of, you're going to be alluding to some sort of societal, of a problem of societal relevance, whereas the direct PVs will really be saying this thing that we are proposing here in this patent application will be solving this problem. And therefore, maybe you could think that if that thing